Section 9.3, Modular Arithmetic. The modulo M system. A modulo M system consists of M elements, 0 through M-1, and a binary operation. Assume today, Sunday is day 0, Monday is day 1, and so on. If today is Tuesday, day 4, what day will it be in 20 days? So what we do is we take 20 and we divide by the modulus, which is 7 days in a week, and we get 2 remainder 6. So if it's Thursday currently, we move ahead 6 days and it will be Wednesday in 20 days. What day will it be in 102 days? So take 102 and divide by 7. We get 14 remainder 4. So we would move ahead 4 days from Thursday and it will be a Monday. So if we consider the 12 months to be a modulo 12 system, with January being month 0, if it's currently October, determine what month it will be in 18 months. So we take 18, divide by the value of the modulus, which is 12. We get 1 remainder 6, so it's going to be 6 months ahead, which takes us to April. What will it be in 4 years and 8 months? So convert everything to months. So 4 times 12 is 48 plus 8, 56 months. Divide by 12, we get 4 remainder 8. We move ahead 8 months, it will be June. Congruence. A is congruent to B in the modulo M system, which is written like this. A, looks like an equal sign with an extra little horizontal line over it. B modulo M, if A and B have the same remainder when they're divided by the modulus value of M. In any modular system, we can develop a set of classes by placing all the numbers with the same remainder in the appropriate modulo class. The solution to a problem in modular arithmetic, if it exists, will always be a number from 0 through M-1, where M is the modulus of the system. So for instance, if we take a modulus 7 system, the days of the week, we look in this column here with the 1, all the numbers in here, in this column, when we divide by 7, we get a remainder of 1. So all of these numbers in this column are congruent to one another because they all come out with the same remainder when we divide by 7. Same thing for each of the columns in that table. So let's try some examples on congruence. Determine which number from 0 to 6 the following numbers are congruent to in the modulo 7 system. So the first number is 60. So we take 60 and divide by 7. We get 8, remainder 4. So therefore it's congruent. 60 is congruent to 4 modulo 7 system. How about 84? So we take 84 and divide by 7. We get 12 with a remainder of 0. So 84 is congruent with 0 modulo 7. And 412, we divide 412 by 7, we get 58 remainder 6. So 412 is congruent to 6 modulo 7 system. Evaluate each of these in modulo 6. So on the left side, the first thing you want to do is simplify the left side. So now we have an 8, so we're going to take the 8 and divide by 6. We get a remainder of 1 remainder of 2, so this is congruent to 2 modulo 6 system. On the left side, we're going to simplify. We come out on the left side with a number that's less than the modulus, so that's simply the answer to the problem. Since 6 is less than the modulus 6. I'm sorry, since 3 is less than the modulus of 6. Determine which number the product is congruent to. So again, you want to simplify on the left side. We find that product, divide by 3. We get 13 remainder 1, so 5 times 8 is congruent with 1 modulo 3. Determine all the positive number replacements less than the modulus for the question mark to make the statement true. So we want to know what number do we add to 5 in order to get a number that's congruent with 7 in the modulus 7 system. So if you look in that table that we had on an earlier slide, you'll see numbers like 2, 9, 16, 23. And we want to pick the smallest number. We can't have a negative number here. It's got to be a positive number. So we can't use 2. So we're going to use 9. So 5 plus 4 gives us 9. So the question mark there would be replaced with a 4. So 5 plus 4 is 9. If we divide 9 by 7, we get 1 remainder 2. Dusty's a chef at a restaurant. His working schedule is to work for 6 days and then he gets 8 days off. If today is the 3rd day that he's been working, determine if he'll be working in 60 days from now. So what's his modulus? His schedule is 8 days, 6 days working, 2 days off. So he's on an 8-day cycle. And right now he's in the 3rd day that he's been working. So first we want to take 60 and divide by 8. We get 7 with a remainder of 4. So if we look at Dusty's cycle, he works for 6 days, he's off for 2 days. He's right here in the third working day of his cycle, and we're going to move ahead 4 days, 1, 2, 3, 4, and he won't be working in 60 days. In 82 days, divide 82 by 8, we get a remainder of 2. So in 82 days, he'll be 2 days later in the cycle, or day 5, and he'll still be working. We want to know now if he was working 124 days in the past. So we do the same thing. We divide 124 by 8. We get a remainder of 4. Now we're going to go backwards. So here he is here. We want to go back in time. So we're going to count back 4 days. And we notice that he would not have been working 124 days ago.